Hello everyone, welcome to week 2 of our exponential function chapter. Now, so today we're looking at the notes from 7.2. So now let's review what is an exponential relationship again. Remember, an exponential relationship is a set of number that grows really fast. Actually, they grow by the same amount every time. So if you look at these numbers, from 5 to 10 is a multiply by 2. From 10 to 20 is a multiply by 2. From 20 to 40, also multiply by 2. And 40 to 80, also multiply by 2. So remember, exponential means you're repeating the multiplication. So if you see a list of number that is multiplied by the same value over and over again, that list of number is exponentially growing. Now, or sometimes it can be exponentially decreasing if it's divided by the same number over and over again. Now, so for example, so let's say I give you a list of number 3, 3.6, 4.32, 5.184, and so on. And I ask you, is this number behaving exponentially or increasing or decreasing? Doesn't really matter. So what you need to do is to test it, you need to divide a term by the previous term. So let's say you took term 2 and you divide it by term 1. So term 2 is 3.6, term 1 is 3. So you use a calculator and you divide it. Now what do you get? Now in this case, you can get 1.2. You go like, okay, so what? I don't know. So let's try the next one. So the next one, what you're going to do is you're going to take 4.32, right, and then divide by 3.6. So divide by the previous term. See what you have. Take a calculator, try it. You get 1.2 again. Oh, okay. I guess cool. Little weird, but cool. So let's take the next term, 5.184, and divide by the previous term, which is what? 4.32, right? You divide by 3%. Let's check it one more time and see what you get. Oh, you get 1.2 again. So this, every number going to the next one is actually multiplied by 1.2. If we continue with all the terms, it will be the next term multiply 1.2 again, multiply 1.2 again. So this is, yes, this list is exponential. Okay, now if you did this test and you don't get the same number from every term dividing by the previous term, then no, it's not an exponential function. Okay, so this is how you can check and to see if a list of data is exponentially growing or not. Now let's go back and talk more about the characteristics of exponential function. Now from last week, we know what exponential function, the one that's increasing, looks like. And also the one that's decreasing. Sometimes you have one that are decreasing, it looks like that, right? So last week we have those picture. So sometime a question will ask you, well, how many x-intercepts do you have for an exponential function? Now look at these two numbers. First of all, what is x-intercept, if you remember that? Okay, so let's say you have the xy coordinate like this, x and y coordinates, right? So what is an x-intercept? X-intercept is when your function crosses the x-axis, which means these 2 points. These are called x-intercept. Okay, it's the point where your function, right? Your function crosses the x-axis, right? So these are the x-intercept. Now, look at our exponential function. Look at the 2 on top. This increasing or this decreasing one. Does it ever cross the x-axis? I mean, this is the x-axis, the horizontal one. No way. It never crossed the x-axis. So therefore, because it never crossed the x-axis, we actually don't have x-intercept. So we don't have an x-intercept for this type of function. Now, so exponential function usually looks like this form. So you have some number times some number to the power of x. And now in this situation, the y value can never be 0. Why is y value never be 0? Because you can look at it this way. Now it doesn't matter what a and b's are, and it doesn't matter what x is. You can never make this value equal to 0. You can never make this thing equal to 0. Okay, so like think about it. Let's say you have some number b to the power of something that's positive. Let's say x is positive, right? So for example, so let's say you have 2 to the power of 3, right? This is 8. This is always positive. Okay, so let's say you have b to the power of something negative. So something that's negative. So let's say you have 2, the base, to the power of your x, which is, let's say, negative 3 this time. Now what do you get? You get 1 over 2 to the 3, which is 1 over 8. This is still positive. Okay, so you might say, okay, so what about 0? So b to the power of 0. Well, okay, so what is anything to the power of 0? So what is 2 to the power of 0, for example? 1. Anything to the power of 0 is equal to 1. This is still positive. Right? Can you see that? So no matter what you do, our function never crosses to the negative area. It's always in the positive area, no matter what x is. So we can never actually cross the x-axis. It's always positive. So therefore, we say exponential function. So one of the feature for it is it has no x-intercept. So exponential function has no x-intercept. Okay? Like you just don't have any. Okay, so the x-axis is actually one of those, like something we call the horizontal asymptote, right? So a line that you can never cross, right? So now find the y-intercept. Okay, so the y-intercept, so we talk about x-intercept, which mean, the result is we don't have any. Now how about y-intercept? Okay, so y-intercept is when x equals 0. So x-intercept is when y equals 0, which can never be true for exponential function. Whereas y-intercept is when x equals 0. So that's easy. X equals 0 is a calculation. You just have to, plug it in to see what that value is and see the result. So for example, what is 2 to the power of, 0? That's 1. Anything to the power of 0 is 1, right? So this graph right here. So that's 1. So our function is simply just crossing that 1 and increasing like this. Okay, so that's our y-intercept. So y-intercept is the point on the graph where your function crosses the y-axis. So the y-intercept is 1. Okay, so it's touching 1. All right, now, so let's look at the next one, see what happened. So again, we're going to set x equal to 0. So if you want y-intercept, set x equal to 0. So y is equal to 3 times 2 to the power of 0. Okay, but 2 to the power of 0 is 1. So that becomes 3 times 1. 3 times 1 is 3. Okay, so that means the y-intercept for this function is going to be at 3. So the graph starts off like this, crossing 3, and go up really fast. Again, it never crosses to the negative side of the x-axis, so don't just approach it. Remember, that's where the asymptotes are, right? So the horizontal asymptotes are here. So you can't cross that line for exponential function. So it has this like horizontal asymptote that you can never cross. Right there, y-intercept at 3. Okay, so y-intercept is at y equal to 3. Okay, so x-intercept nothing, y-intercept at 3. So one more. So how about this one? Well, you can see a pattern on here already. So if I set x equal to 0, this is going to be y equal to 10 times 2 to the power of 0, which is 1. Well, 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10. So the y-intercept is at 10. So right here, what will the function look like? Well, it will look something like this, crossing 10. So go up, go up, go up, go up to 10. There you go. And crossing it. Like that. Okay. So what does it look like right now? So if you go back, I hope you can see a pattern. The y-intercept for this last one is when y equal to 10. Now this number, y equal to 10, is also the number in front of the function in front of the base. It's the coefficient in front of the base. Look at that. Now, see that y equal to 3 right there? On the second question, is that 3 right here? Now, you might say, well, what about the first one when y equal to 1? Well, that one works too in a sense, because even though there is no 1 in front, well, no pun intended, no 1 in front, but there could be a 1 in front, right? 1 times 2 is 1, so it's a hidden 1. So therefore, that's it. We have the law, I think, already. The leading coefficient, which is this term right here, the number that's in front of the base of the exponent, this leading coefficient, is the y-intercept. Okay, so if you want to look for the y-intercept, you just have to look at the function and see the number in front. Okay, now, then we can look at a couple of examples. Now, the final thing we did determine, so now we know 3 things. We know that exponential function always have a horizontal asymptote. We also know how to draw is y-intercept now, which is just the coefficient in front. So the only thing we need to learn to actually draw this kind of function, no matter what a and b number they give us, is to figure out if it's decreasing or increasing. Right? Once we know that, once we know it's increasing or decreasing, that's it. That's everything that we need to know about the function. So therefore, okay, so what about those, well, increasing and decreasing thing? Well, okay, so we're going to try and plot these one and see what happens. Is the function decreasing or increasing? So we're going to plot the same value, right? We're going to use a list of x and y value, -1 to 2, -1, 0, 1, and 2, and find out the y value and try to plot it. So I will do it rather quickly, so you can stop the video or you can fast forward until we get all the numbers. So, for example, 3 to the power of -1. So what is 3 to the power of -1? So 3 to the power of -1. So we have an x in here, so we're putting -1 into the x. So 3 to the power of -1 is 1 over 3. Right? So negative exponent is 1 over. So it's 1 over 3. So the next one is 3 to the power of 0, which is 1. The next one is 3 to the power of 1, which is 3. The next one is 3 to the power of 2, which is 9. So 1/3, 1, 3, and 9. So these are all data points. So the first data point is going to be -1 and 1/3. So -1, 1/3, right there. And then the second point is 0 and 1, 0 and 1. The third point is 1 and 3, 1 and 3. The fourth point is 2 and 9, so 2 and 9. There you go, right? So you can see, and then you can add the horizontal asymptote to it, right here. So you cannot touch this line. Then you can sync up everything together, which in this case would be, so approaching but don't touch. So approach at 9 but don't touch it, right? And then hit the first point, second point, third point, and then grow really fast, fourth point. There you go. There we go. So this one is obviously increasing, as you can see. Right, it's growing. Okay, next one. Again, I will do this number rather quickly. So 1/2 to the power of -1. So this one, think about 1/2 to the power of -1, which flips it over, it becomes a 2. Okay, 1/2 to the power of 0 is 1. 1/2 to the power of 1 is 1/2. 1/2 to the power of 2 is 1/4. So this one, again, so these are data points. -1, 2, for example, is right here, -1, 2. And then we plot the rest. The next point is what? It's 0, 1. So it's here. The next point is 1, 1/2. It's here. The next point is 2, 1/4, which is here. Now this is obviously a decreasing graph. You can see that. So it's approaching that 0 but never touching it. Again, that's a horizontal asymptote. So this graph, decreasing, right? So sometimes the graph can increase, sometimes the graph can decrease. So what's the difference between these two functions? Why is one of them increasing, one of them decreasing? Increasing, one of them decreasing. I think the only difference between these two is the base. Look at the base. This base is 3. This base is 1/2. Maybe when the base is a fraction that's less than 1, it's decreasing. And when it's a number that's bigger than 1, it's increasing. Let's test that theory. look at the next two set. Now, the first one right here, the base is 2. The second one right here, the base is 1/3. The number in front doesn't matter. Remember, the number in front is just the y-intercept. So we don't look at that to determine if the graph is increasing or decreasing. This is just your first point. So for example, that's 0.5 is a point that is on the y-intercept, y-axis. Okay, so for the second one, that 4, right? This 4 right here, that is just saying that, you have a point at 4. That's it. Like, that's the y-intercept. So now let's look at the other value. So -1. So when x is -1, what do you get in here? It's going to be 0.5 times 2 to the power of -1, which is 1/2, right? So this is 1/2. So it's 1/2 times 1/2. This is actually a quarter, 0.25. So when x is 0, you get 0.5. When x is 1, you actually get a 1. And when x is 2, you get a 2. So again, you can check this number. Now I will do this one very quickly. When x is -1, this first one is actually 12. When x is 0, you get a 4. When x is 1, you get like a 4/3, which is, okay, weird, 1.3 approximately. And then when x equals to 2, you get a 4/9, which is again a weird number. This is about 0.4. Okay, I think that actually confirms our guess earlier, right? Look at these numbers. The first one right here, the value is increasing because the base is a 2, right? The yellow 2, the base is 2, which is bigger than 1, is increasing. And whereas this next one, look at the number, it's 12, 4, 1.3, and then 0.4 is decreasing because the base is a fraction or something less than 1. So I think that's our pattern. Okay. Now, so for this 4, right? So we have an increasing one, a decreasing one, an increasing one again, and decreasing one again. And the only difference between them that you can tell is the base. Okay, so now let's write it down. We don't even have to draw those two in a graph. Let's write it down. So the function is increasing if the base, right? Now, so again, what is the base? So you have an exponential function, is a times b to the power of x. So the b is the base. Okay, so if the base is bigger than 1, the function is always increasing. Okay, so bigger than 1. So bigger than 1. Now, if the base is between 0 and 1, that means now we're not talking about negative in here. It's just like a number that's less than 1. For example, 0.5, 0.2, or like a fraction. Then the function is decreasing. Okay, so this is a fraction. It could be a fraction or decimal. Okay, so fractions or decimal. All right, so now let's see if we can actually join everything that we know together and do these matching questions. So I have 4 graphs, and associated with them is 4 equations. So let's see which graph matches with which equation. So this first one right here, look, that is the y-intercept. That means your graph has to touch a 3. Now no other graph has that, so you're lucky. So that means we can actually tell by just looking at the y-intercept. Look at this one. The other one, y-intercept is at 4. And the other one is at 4. And the last one, the y-intercept is at 2. So none of them are the same. So y-intercept at 3. And what else? Look at this base. The base is between 0 and 1. That means this is a decreasing function. Okay, decreasing function. So y-intercept at 3 and decreasing. Decreasing means it goes this way, right? Increasing goes the other way. So y-intercept at 3, decreasing. Oh, yeah, right here. So look at that y-intercept. Y-intercept at 3. Okay, and it's decreasing. So that's it. So that one, C. Okay, so we look at the next two simply, exactly the same way. So next one, look at that. Y-intercept at 4, and this point is 3, so that is bigger than 1, that's increasing. Okay, so it's increasing, and 4, I think, hey, that's the one right below it. This is increasing. That y-intercept is at 4, so that's perfect. Match. So B. Okay, so next one, let's see. Next one is 4. So 0.5, that's decreasing because it's less than 1. So decreasing, that means it goes the other way, and the y-intercept is at 4. So right here, y-intercept at 4, decreasing. There you go, D. Perfect. And then last one, y equal to 2 times 4 to the power of x. This is y-intercept at 2. This is 4, so it's increasing, right? Increasing. So therefore, we can actually look at that is must be the last remaining one, A, right? So look, y-intercept at 2, y-intercept at 2, and then it's increasing as a graph. Okay, so y-intercept at 2, and it's increasing. So there we go. So this is A. So that's for the last one, which is at A. Okay, so if they ask you for y-intercept or x-intercept, remember, so all we have so far, x-intercept, nothing. Y-intercept, look at the leading coefficient, which is the A term. Increasing or decreasing, look at the base. If it's bigger than 1, it's increasing. If it's less than 1, then it's decreasing. It's actually not that difficult. Now, the one final thing that you need to consider, so the one final thing that you will need to consider when doing your assignment for this week, now I have the numbers in here, is there are two things. Number one is in one of the question, which is 12E, you see they have a function, okay, it's kind of weird. I want to talk about the thing that has a E in it, then they actually have E. So you have something like this. It's 2 times E to the power of X. So your base is this E thing. Now this E is actually a number. It's called the Lecco number. So this number is like pi. It's one of those special number in math, but you haven't learned this one yet. You will later on. So this is a natural number. It's about 2.71. It's like pi is 3.14. This one has something to do with calculus, and it has something to do with golden ratio and calculus in math. And this number is 2.7. So you don't have to know exactly what the numbers are is, because you can find a calculator for once. Second, only thing you need to know is that it's bigger than 1, right? Because when it's bigger than 1, you know the function is increasing or decreasing, right? So that is the only thing you need to know. Now, another thing, so y-intercept, base, increasing and decreasing, they might also ask you for domain and range. So I'll say it one more time. For all exponential function, okay, so for all exponential function that has the form y equal to a times b to the power of x. Now, I'm only talking about this when they're all positive, right? So if something is negative, then we will need to look at it very differently. So for all exponential function in this form where a and b are positive, the domain, which is what are the x value? Well, x value. Look at all our function. Is there an x value that we cannot use? Nothing. We can always put any x value that we want. Is all real number. X is all real number. X can be anything. All real numbers. For range, which is what are the possible y value, look at every single function. They all go up really, really high, right? Look at the function, like look at this one, look at the one that is like right here. So they all go up really high, and the only one number that the only restriction that the y value has is that it can never actually get below 0. So that means the y value for any y value in the function is always bigger than 0, right? It cannot even equal to 0 because it never touches that asymptote, right? The horizontal asymptote. So it has a horizontal asymptote, never touches it, and so this is domain and range for all exponential function. Okay, so that's it. The homework question, I'll put it on the portal too, on our coursework page too, of course, but it's actually page 451. You have to download the book files again. Question number 1 and question number 11 to 13. When you're done, take a picture, submit it on the portals as your homework for assignment for this week. Now, next week, we will lead our graphing calculator again. So we will start using our graphing calculator again. So if you have your graphing calculators at home, good, you're going to use it. If you don't have your graphing calculators at home, you might have to I think the school allows you to go back and get some stuff from your lockers, but you will have to sign in a given, and you have a time slot that you can go in. So I think some people have already done that, right? Going back to class, to school, and then getting something from the lockers. So if you have your graphing calculators in your lockers, you need to get that. Otherwise, starting from next week, none of the lessons will actually make any sense. Okay, so that's it for this week. Have a nice week. Stay safe. Stay healthy. Goodbye.